This video is on section 6.6 notes. Again, we've already had one section, so we're going to continue solving trigonometric equations, but these ones get a little bit more complicated. So for this first example, it says we're solving the equation sine of 2x equals sine of x. And so the strategy that we're going to use to solve this equation is that we're going to use identities in the equations. So here we have a double angle identity. We're not necessarily going to use a double angle identity for any type of equation we could see where this strategy could be used. But for this specific equation, the double angle identity is what we can see happening. So I can see that sine of 2 theta is 2 sine theta cos theta, and so I'm going to make that substitution. So I have 2 sine x cos x for the left side, and then the right side is sine x. And then at this point, this is kind of like a factoring problem where we have 2 variables on the left side and 1 variable on the right side. And so I'm going to go ahead and subtract the sine x over to the left side, and I'm going to make the whole equation equal 0. So I have 2 sine x cos x minus sine x equals 0. And then between this first term and this second term, I have a GCF of sine x. And so I'm going to go ahead and factor out the sine x, and then I will write what's left over. So 2 sine x cos x with the sine x factored out will leave a 2 and a cos x behind. And then sine x divided by sine x will leave just a 1 behind, kind of as a placeholder. If this is hard for you to visualize, if factoring in terms of trig is difficult, remember that we can always write it off to the side with regular variables. So I could say this is like 2xy minus x. So I'm thinking of sine as being the x variable, cos as being the y variable. And then if I were to factor this, I'd say, well, there's a GCF of x, and then I have a 2y for the first term minus 1 for the second term. So you can factor this part if that's a little bit easier. And then I could say, well, the first factor is going to be x equals 0, and the second factor is going to be y equals 1/2. Over here, that means that the first factor is sine x equals 0, and the second factor is cos x equals 1/2. And then from there, I can go ahead and solve these more simple trig equations. And so I know that x is sine inverse of 0, and x is cos inverse of 1/2. And sine inverse of 0 is, sine inverse of 0 of the ratio 0 is 0 and pi and 2 pi. So I'm going to write those down. So x equals the angle 0 and pi and 2 pi and 3 pi and 4 pi and 5 pi and 6 pi, so all of the pi's. And the interval says starting with 0, ending with 2 pi, so don't go past 2 pi. And the interval says to include 0, but do not include 2 pi, so I'm not going to include that answer. So here are the 2 answers on the unit circle that I should include based on the interval. And then cos inverse of positive 1/2 would be pi thirds and 5 pi thirds. All right, for the next problem, we have 6 cos squared of x over 2 minus 7 cos of x over 2 plus 2 equals 0. So this is a problem that is a quadratic in terms of cos, and so our method for solving this one is going to be to factor. So here you can think of this in terms of trig if you are comfortable factoring trig. So I'm going to go ahead and write this out. 6 cos squared of x over 2 minus 7 cos of x over 2 plus 2. And since this has a number in the front for the a value, this would be like a slide divide problem, or you could use the box method, or you could do guess and check. You could factor by grouping. There's a lot of different ways to factor this. I like to use the slide divide method, and I'm going to write it over here off to the side. 6x squared minus 7x plus 2. So this would be the quadratic that I would be factoring. So if we were using the slide divide method, we would look for two numbers that are going to multiply to 6 times 2. So two numbers that are going to multiply to 12 and add to negative 7. So two numbers that multiply to 12 and add to negative 7. So 4 and 3 multiply to 12, add to 7. And to make those a negative 7, I just need both of them to be negative. So negative 4, negative 3. So in my parentheses, x minus 4, x minus 3. And then the number that I slid is the number that I divide by. So I slid a 6, so I'm going to divide by 6. And then I have to reduce each of these fractions. So 4 over 6 can reduce to 2 over 3. 3 over 6 can reduce to 1 over 2. And then we do bottoms up to the front, bottoms up to the front. So 3x minus 2, 2x minus 1. So those are the factors. And then if we want the solutions, x equals positive 2/3, which you can actually see up here a little bit easier. X equals positive 2/3, and x equals positive 1/2. Okay, so if I take this, but I go ahead and do it with the trig instead, then I'm going to have cos of x over 2 equals 2/3, and cos of x over 2 equals 1/2. And I'm going to go ahead and do this one first because this one is on the unit circle. In fact, we just did it up here. Just did it up here for this problem. So, okay, so cos of x over 2 is 1/2. So that means that x over 2 is cos inverse of 1/2. And so we have two solutions here. We have x over 2 is pi thirds plus 2 pi k. Whenever I have a problem like this with a multiple of an angle, I always set it up to find all solutions, even though I'm on the interval from 0 to 2 pi. And I do that just because it's a little bit easier for my brain to find the rest of the solutions. I can't talk and do math at the same time. To find the rest of the solutions that I need to find. The second answer was 5 pi thirds. So pi thirds and 5 pi thirds are what we get if we look at the unit circle to see where cos is 1/2. And I know that because we just got that answer for the first example. Okay, so now I'm going to go through and I'm going to get this x all alone by multiplying by 2. So times 2, and then I'm going to take this entire thing and multiply by 2. I'm going to do times 2 and take this entire thing and multiply by 2. So x equals 2 pi thirds plus 4 pi k. That's one set of answers. X equals 10 pi thirds plus 4 pi k. Okay, so for this we get one answer. We get x is 2 pi thirds. 10 pi thirds is bigger than 6 thirds, and so that's bigger than 2. So this one is too big, this is not on the interval. And then if we were to add 4 pi, we'd get something bigger than 2 pi. So we only have one answer from this factor. And then I'm going to have to do the same thing over here, but here I'm going to get decimal answers. Okay, and what I did is I took these little shortcuts from the notes that we did before, 6.6 part 1, so that you could have them again. So this is going to help me with my decimal answers. So I'm going to say that x over 2 equals cos inverse of 2/3. And I'm going to have to walk through this process again because I know that the x over 2 gives me kind of funky answers. And so I'm going to find the kind of the formula to find all of the answers, and then I'll use it to find the ones that are on this specific interval. So I'm going to grab my calculator and make sure that I am in radians, and I am. And I'm going to do cos inverse of 2/3. Okay, and so the cos rule says S is cos inverse of A. It doesn't matter if S is positive or negative. And so it says the first rule is it's just S plus 2 pi k. So this is x divided by 2 is approximately S plus, so that's 0.841 plus 2 pi k. And I'm going to take this 0.841 and I'm going to store this as, where's the SQR? S is right down here. I'm going to store this as S. Alpha ln is going to store it as S. Okay, and now I'm going to go ahead and take this and just multiply by 2 times 2. Okay, so I have x is approximately 2s 1.682. Okay, so I took this decimal, I stored it as S, and I did that pretty fast. I don't know if we've done that in this class yet where we stored a letter, so I'm going to go ahead and go through that process again. So cos inverse 2 divided by 3, there's my decimal. To store a decimal in the calculator so that you can access it again and access the exact value, you just hit this store button right here, STO. And then you can choose any of these letters that are in green. Choose any letter to store it as, and I stored it as S because that's what it is called on our little formula sheet over here. And so I did alpha, and then I hit the ln button because that's where the S is. And so now if I hit alpha ln, if I type in an S, it's just going to spit out that decimal for me. Okay, so there's my first set of answers. For my second set of answers, x over 2, for cos, the second set of answers is if you do 2 pi minus s and then plus 2 pi k. So I'm going to do 2 pi minus s for my second set of answers, 5.442. Plus 2 pi k. And then I'll go ahead and multiply by 2 and multiply by 2. And here I can just take that decimal and double it, 10.884 plus 4 pi k. So my two sets of solutions come from this, 1.682 plus 4 pi k, 10.884 plus 4 pi k, and I have to think about which of these decimals are between 0 and 2 pi, which is 6.28. And so the only decimal that's between those values is this first one. And if I add 4 pi, it's going to be too big to get a second answer. And this answer is already too big. So 1.682 is the only decimal answer that we get from that factor. And so this problem has these two answers. All right, and if we wanted to, we could go back through and just make sure that these answers are right. I'm going to go ahead and store this. And I'll store this as X. There's an X up here, this X button that we use when we graph. There's also a green X down here. You can store it in either place, it doesn't matter. So I'm going to use this X button up here. And what I'm going to do now is I'm going to type in this and just make sure it equals 0. So 6, cos of X, remember that this just means that you're taking cos of the angle and you're squaring it. That's what that notation means, but the angle happens to be X over 2. So it's cos of X over 2, and then that whole thing is being squared. So cos, and then I'm going to put this in parentheses, cos of X divided by 2, end parentheses to finish the angle, end parentheses to finish the expression cos of the angle. So 6 times cos squared minus 7 times cos of the angle plus 2. And since I'm typing in X, it is taking this decimal that I stored for X and it's plugging it in for me. And I get 0 because that decimal was one of the correct answers. I could do it again also with 1.682 just to make sure that my answer was correct. And I could do it again with 2 pi thirds, make sure that answer was correct. So that's one way to check your answers when you're doing problems like this where there was a lot of work, just to make sure you did things right. Okay, we have another quadratic equation here, but this one kind of mixes those first two strategies. So if we look at this, it says cos squared. So we have a squared term, and then we have a sign, and then we have a number. So this is kind of like if we had x squared minus y equals a number, which is a quadratic equation because it has a squared term. But it's not a quadratic equation that we typically solve. We don't usually have two variables when we do stuff like this. Well, actually, that's not true. We do, but we don't usually solve them with the quadratic formula, which is what we're about to do. So we're actually going to combine the first two strategies where we're going to use an identity. But then we're also going to work with a quadratic equation. It's just not going to be a quadratic equation that's factorable. And whenever you have a quadratic equation that's not factorable, you use the quadratic formula. So we're going to go ahead and we're going to get this in terms of one trig function so that we don't have two different trig functions. And the way that we can do that is we can use our Pythagorean identity. So we know that cos squared is the same as 1 minus sine squared. And so the first thing we're going to do is take that cos squared and replace it with 1 minus sine squared. So I end up with 1 minus sine squared alpha minus 0.2 sine alpha equals 0.9. And then whenever I work with quadratics, that x squared term, or in this case, the sine squared term, I always prefer for that term to be positive. It's just a little bit easier to factor if the leading term has a positive coefficient. So I'm going to go ahead and I'm going to take the negative sine squared and I'm going to add it to the right side. Plus sine squared plus sine squared. And then because I'm adding this to the right side, I'm going to move everything else over to the right side as well. So I've made the quadratic equation equal 0, and I'm going to write it in order. So I'm going to put the squared term first. And then 0.9 minus 1 is minus 0.1. And so what I'm really working with here is I'm working with a quadratic equation that is 1x squared plus 0.2x minus 0.1. This is what I actually have when I look at this. And you could possibly solve that by factoring, but you'd be looking at what multiplies to 1/10 and what adds to 2/10, and thinking in terms of fractions is often a little bit more difficult. So in this case, I would just do the quadratic formula. So I'm going to do x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And that's going to give me my two solutions, most likely decimal solutions. Okay, so let me type this in. So to type it in as a fraction, I'm going to hit the green button, and then y equals, and now I can put a fraction on the screen. And I've got negative 0.2 plus square root 0.2 squared minus 4 times 1 times negative 0.1 divided by 2 times 1. Okay, so here is my first answer, 2.32 approximately. Sorry, 0.232 approximately. And so that's what x equals, but I know that's really what sine alpha equals, 0.232. So if I want to go ahead and solve for alpha, then I know that alpha is sine inverse of 0.232. And so I'm going to go ahead and solve this. And I have, in my notes, I have the shortcuts for sine. So I need to pay attention to when I do sine inverse if my s is greater than 0 or less than 0. So I'm going to do sine inverse of this decimal. And I get this, okay? So sine inverse is an s value that's greater than 0. It's a positive s value, and so I'm going to do these two formulas right here. So s plus 2 pi k. So alpha is the value I just got on my calculator, 0.234 plus 2 pi k. And then I'm going to take this and I'm going to do, for the second answer, it is pi minus this value, 2.908. Plus 2 pi k. Okay, that's how we get the two answers. And then for the other two answers, I need to go back to my quadratic formula and find the second value for x. So I'm going to go back up to my quadratic formula here. When I highlight it like this, if I press enter, I copy paste it. And I just need to go back and change the plus in here to a minus. There we go, change that to a minus. There's my second decimal, negative 0.432. So that means that sine alpha is negative 0.432. And so alpha is sine inverse of negative 0.432. Okay, so sine inverse of this answer. There we go. There's our s value. Now this time, our s value is less than 0. So our first answer is going to be s plus 2 pi. Our second answer is going to be pi minus s. So s plus 2 pi is our first answer, 5.837. Second answer is pi minus s. Pi minus S. 3.588. Now, we only leave the plus 2 pi k's if the instructions say to write the answer on the interval from negative infinity to positive infinity. And this didn't say that. Didn't say negative infinity to positive infinity. It just said from the interval 0 to 2 pi. So what I'm going to do is I'm going to write my final answer as just these decimals, but I know that this would have helped me get more answers if my interval had been larger. So I'm going to say alpha is 0.234, 2.908, 5.837, 3.588. You could put them in numerical order if you want to, smallest to largest. I did not. Okay, so there's the 4 answers, and we could check them just like we checked the last problem. I'm going to go ahead and try checking this one. So I'm going to store this as x. So now every time I type in x, it's just going to plug this decimal in, and now I can type the original problem. So the original problem says cos alpha squared minus 0.2 sine alpha, and I should get 0.9 as the answer if I do that. So cos, actually I'm going to type this in with parentheses around it so I can square it. Cos x squared, so there's our cos squared, minus 0.2 sine, and that should give me 0.9, and it does. So that means I got it right. Okay, last problem says that the method we're going to use here is a quadratic equation. We're going to square each side. And if you look at the initial equation, you're going to see this is not a quadratic. It just has a plain tan, this is not squared, equals a plain secant, this is not squared. So the reason that we are using the method to solve this of squaring each side is because on our sheet, the only thing that relates tangent and secant directly to each other is the Pythagorean identity. Tan squared and secant squared only have a direct relationship if both of them are squared. And so if we do this, if we square both sides and put a tan squared on the left side and a secant squared on the right side, then we can do a substitution and get the entire problem in terms of tan or the entire problem in terms of secant. And once the problem is in terms of one variable, it's easier to solve. Okay, so keep that in mind when you're looking at these. If you have 2 different trig functions, that's kind of like having 2 different variables. And then you would be looking for how can I get those variables to relate to one another. So we're going to take the 2 sides, tan of 3y and then plus 1. This is not tangent of 3y plus 1. If they had written that, this would have to be in parentheses. So this is a tan of 3y with a plus 1 tacked on the end. Okay, so we're going to take the left side, we're going to square it. We're going to take the right side, and we're going to square it. And so to do that, I'm going to write each of these sides twice. Okay, so tan times tan is tan squared of the angle. Tan times 1 is tan. 1 times tan is tan. 1 times 1 is 1. So this is tan squared. 1 tan plus another tan gives you 2 of them. Okay, so on the left side, it makes sense. We clearly have a quadratic. Squared term, tan squared, and a regular tan. This is a quadratic. On the right side, root 2 times root 2 is the square root of 4. That's just 2. Secant times secant is secant squared. Okay, and then I can take the secant squared and I can replace the secant squared with a 1 plus tan squared. So I'm going to take out the secant squared. I'm going to replace it with 1 plus tan squared of the same angle. Okay, the reason that I'm taking out the secant squared and substituting in for the secant squared is because I cannot substitute out the tan squared. I could substitute out the tan squared, but I couldn't substitute out the tan. And so if I substitute out the secant squared, then I get everything in terms of tan, and that will be easiest to solve for. Okay, so I'm going to go ahead and distribute this 2 to my parentheses. 2 plus 2 tan squared. Okay, now if I have 2 tan squared on the right side and 1 tan squared on the left side, then to solve this quadratic, I want a positive number of tan squareds when I end up factoring it or using the quadratic formula or whatever. I prefer my tan squareds, I just prefer my squared term to be positive. So I'm going to minus 1 tan squared from the 2 tan squared. And so that tells me I should be taking everything from the left side and moving it over to the right side. So I've got 0 equals tan squared minus 2 tan plus 1. Okay, so what I'm really working with here is 0 equals x squared minus 2x plus 1. This is what I'm actually working with. So if I were to factor this, this is not a slide divide problem, not a box method, not a whatever, because the x squared term is alone. It has a coefficient of 1. So to factor this, I just need to find 2 numbers that multiply to a positive 1 that add to a negative 2. Multiply to a positive 1, add to a negative 2. And the numbers that do that are negative 1 and negative 1. So this factors to x minus 1 and x minus 1, which means that there's only one solution for this factoring problem. It's x equals 1. That's the one solution for this factoring problem, which means that for this trig equation, there's just going to be the one type of solution, and that's going to be tan of 3y equals 1. So we can say that 3y is tan inverse of 1. And so now I just have to imagine on the unit circle, where is a y coordinate divided by an x coordinate that gives me 1? And hopefully at this point you're kind of recognizing these tangent ratios, but a y coordinate divided by an x coordinate that gives you 1 is root 2 over 2 divided by root 2 over 2, and that happens at pi fourths. So we're going to have 3y equals pi fourths plus, and then since this is tangent, we just say plus pi k. The answers repeat every pi k, and we don't have to do both options. We can just say one option plus pi k. And then we're going to go ahead and solve for just the y. And so I'm going to divide by 3, divide by 3, divide by 3. And so to get all of my solutions here, should have given myself more space. Y equals pi fourths divided by 3 is pi twelfths. Pi twelfths plus pi thirds k. This is how I get all of my solutions. Okay, so now they didn't say they wanted the answers on the interval from negative infinity to positive infinity. They said they wanted the answers from 0 to 2 pi. So I'm going to go ahead and find the answers on the interval from 0 to 2 pi. So the first one is pi twelfths. So 1/12 as a fraction. Okay, plus 1/3 5/12. Makes sense, you're adding 4/12. Plus 1/3 again is 3/4. That makes sense because another 4/12 would be 9/12, which reduces. We're going to do it again. 13/12. We're going to do it again because we're not to 2 pi yet. This is not 2 pi yet. 17/12. Going to do it again. 17/12, that would be 21/12, which should reduce. 7 pi fourths is really close to 2 pi. 8 pi fourths would be 2 pi, so we're very close. 25/12 is bigger than 24/12, and so we're past 2. So at this point, I would stop and I would say these are all my answers from 0 to 2 pi.